All right, so we're going to use substitution again. Same idea, but take a look at it. Nothing is set up nice and neat for us. We're going to have to rework some stuff in order to substitute. All right, so here's what I mean. Somebody pick one of these, X or Y. Y. All right, so we're going to solve for Y. So if I solve for Y, I'm going to move X to the other side. Just like that. And you can write that however you want, in whatever order. Then we're going to substitute. So the other assignment we did today was substitution, right? And it looked like this. Now we're going to plug this stuff into here. Now, here's what I'm going to do. I'm going to do this the long way, and then I'm going to show you on the graph how it's much easier. Okay, here we go. So, not every graph will be that easy to tell, though. So I'm going to plug it in just like this. So using powerful highlighter, right? All of that got plugged into there. Whenever I square something like that, I need to put it in parentheses just the way I did there. How do you square something that's a binomial? How do you square a binomial? What do you have to do? Okay, you got to use parentheses, but how do I square that thing? Yeah, good. So I've got to multiply it out twice. So I'm going to go to a new page here. Just do this off to the side. If I'm squaring that, I have to multiply it out twice and use the distributive property, right? So I'm going to do this pretty quickly. That's now a positive x squared. Negative times the negative is positive. That's also a positive. Another negative times the negative is positive. So the result of this is this guy right here. Now this is just the part that was squared, right? I did a little side note, side page here. Just the part that's squared is equal to this. So let's go back. We now have x squared plus all that stuff. I'm going to copy this over to another page because we got to solve this thing now. Okay, so x squared plus 6x plus 9 equals 9. All right, now we just did a bunch of this stuff for our last unit that we did, right? We did stuff like this all the time. So what should I do first? Combine. Awesome. I'm going to combine these two. So now I've got 2x squared plus 6x. Now I'm going to do this in the same step. Notice how there's a 9 on both sides. What happens if I do this? It's gone and it's equal to 0, which is what we want, right? When you're solving a quadratic like this, quadratic is an x squared and an x. We want it to equal 0. There was one very similar to this on your quiz. One very similar to this sort of thing. Who knows how to solve this one? Yep. Bingo, right? So there's a common factor of 2x. That leaves x plus 3 on the inside. Now, when we have a common factor like that, x is its own factor, which means one of the solutions is 0. That's a thing that's often forgotten. Got to get used to that. Okay, another thing Another solution is the opposite of this x plus 3. Negative 3, right? It's all tying together. Everything we did last couple weeks. We have two solutions. That means, if we go back to the original problem, there's going to be two intersection points on the graph. Because the original question said, we want to find the intersection points of the graphs, right? What do we have? We have a line. Notice how there's no exponent anywhere? That's a line. And we have a circle. So if a line crosses through a circle, there are three different things that could happen. If we have a circle and a line on the same graph, I should say, there's three different things that can happen. It could either cross through twice. What's another thing that could happen? It could miss it completely. In this case, there would be no solutions. And it could just touch it once. Imagine like a ball sitting on the ground, right? It's only touching at one point, okay? So 0, 1, or 2 solutions in this situation. Now, we just came up with two solutions where x equaled 0 and x equaled negative 3. So, I want to show you something. We could plug those x's back right in here. X equals 0, x equals negative 3, to figure out the y coordinates for each one. Now, we're going to do that on other questions, but I'm going to kind of, just for time's sake, I'm going to skip ahead. Down here, what they wanted us to do, actually, was to draw the graph of this circle. Here's how you draw the graph of a circle. This number over here tells us the radius squared. The radius of a circle is the distance from the center, right? So if the radius squared is 9, then what's the radius? Well, if 9 is already squared, what number was squared to make 9? 3, right? So yeah, that gets confusing, but 3 is your radius. Now, when it's just x squared and y squared, it means the center is right there at the origin. There's no other numbers in there. It's not shifted side to side. All right, so our circle looks like this. At the center, and it goes out 3. Oh, maybe my center was off a little bit. There we go. That's a little better. All right, so we can see there's two spots where the line hits the circle. One of them was at x equals negative 3, which is right here. If you count them, 1, 2, 3, right? That's 1 point. Let's make it red. The other point's down here where x equaled 0, right? Now x equals 0, correct? And x equals negative 3. Up here, the coordinates would have been negative 3, 0, where this is the x and that's the y. Down here, x equals 0. What's the y coordinate? Yeah, because our circle had a radius of 3, right? In all directions, it went 3. Left, right, up, and down. So those are our two solutions. What are all the answers that apply? Well, we got them right there. That's where the graph had the circle and the line intersecting each other. Now, we could have just done that from the graph. We could have. If you didn't know how to graph a circle, though, you would have had to solve it the long way that we did, right? We would have had to say, how can we make a circle cross at those two spots? There's only one way. All right, now, let's try one more, maybe two. Let's try this one. I'm going to get you started by saying this. Let's transform. Actually, let's do this. Let's substitute this in for y right now. Substitute that in for y. It's going to be a quadratic. It's going to have some x squareds and an x's in it, and we're just going to have to solve it. I'm just highlighting the stuff that was plugged in, just substituted right there. All right, now I'm going to distribute. Just like that. That's a 2 over there. It's a terrible 2. Somebody help me combine these. On the left side, I can combine 2 things. Good. All right, so we have, wait, just to point that out, right? You can combine the 2 x's. So we got 4x squared. This is a 1x. That's a negative 8x. Right? Okay, equals 2. Now, since it's a quadratic, we want to get everything on one side, just like we did last week, the week before. So we're going to move that 2 over this way. Now we have to, our favorite F word, factor. Right? What? What's your, no, wait, don't answer that. Nope. Fun! Yeah, there we go. All right. Anyway, I used to say, what's your favorite 4-letter F word? And it would be FOIL, like for distributive property, FOIL. First, outside, inside, and last, FOIL. Okay, anyway, we're talking about factoring, right? So let's factor this stinker right here. Now, here's one hint for you. Notice what it says up here. Hint, hint, hint. It's telling us that x is equal to 2 is a solution. So if x equals 2 is a solution, right, then x minus 2 is one of the factors, right? It has to be. Because if we did this, this would mean that x equals 2. Now, how nice is it that we have one of the factors? We can just figure out what the second one is. Real nice. Real quick-like. Something you got to look out for, though. We need the 2 x's to multiply to equal 4x squared. And we need the 2 numbers, these 2, to equal negative 2. So let's address this one first. What's this have to be? What times negative 2 equals negative 2? 1. Yes. The other one's going to have to be 4x. It has to be 4x because when I distribute to check my answer, those 2 have to multiply to equal this. Right? They have to. So we could have worked it out the long way, but if you use your hint, it's much easier to figure out the other factor. Now, if this is the case, then what is the solution to this? We've seen this sort of thing before. How do I find the solution to 4x plus 1? Yep. Good. I make it the opposite of adding 1, which is that right there. So we already know one solution. This is the one we know right there. Now, Con wants us to answer this, right? What's this solution? So if I plug in negative 1/4, I just have one piece of the coordinates, right? I need to find the y coordinate. How can I find the y coordinate? Plug it in. So let's go back up. This looks like a pretty easy one to figure out right here. All right, x plus y equals 2. Or you could plug it into the beginning. It doesn't matter to me. All right, so let's do a new page here. We know x plus y equals 2. And we know our x coordinate was negative 1/4. So now I'm going to plug that in. And now I'm going to solve. So I'd have to add 1/4. And you can use decimals as long as they have an end to them. Okay? So non-repeating decimals are okay. So for example, we know 1/4 is 0.25. What do you get if you get 2 plus 0.25? 2 point. Yeah, there you go. Now, if you wanted to answer it as a fraction, you'd have to answer it as an improper fraction like this, 9/4. Either one will be okay. All right, if you wanted to, you could check the answer all the way back at the beginning by plugging both of those back in here. But you don't really have to, okay? I'm going to stop there to give you some time. Okay, let's try those two questions. I did have one other one that I would do. It looks like this. I just want to point out, I'll just give you the main idea real quick. We would take this and do what with it? What would we do? We'd substitute right here. So it would be this kind of long-looking thing that we'd have to do a lot of distributive property on. I want you to notice one thing, though. Right, I substituted this into there, right, that whole thing into there. What can I do with the +1 and -1? Cancel. Yeah, they'll cancel out. So what you'll be left with is 2x squared like this. And I want to give you one last thing. I won't finish this one out, but when you square this, what is that squared? A lot of people think it's just 2x squared, but what is it? It's 4x squared. I wanted to point that out. For this one, you'd have to write out twice. Right, these are extensive, long problems. Right, so we'll have time to work on this tomorrow, or sorry, the next time you come in. These problems take a while. These are on the SAT. You'll have at least one of these stinkers on there. Okay, along with the one we did earlier today. There'll probably be two of those things. All right, let me assign it to you.